Now let us learn how to take the negation of a compound statement. So here we are seeing the examples of negations of the fundamental compound statements using the logical connectives. First one, we study how to take the negation of the conjunction, that is negation of P and Q. Now if you see, that is given by negation of P or negation of Q. So what happens is, while we want to take the negation of AND, we replace individual statements with their individual negations and change the AND to OR. And exactly opposite way happens if we want to take the negation of P or Q, that is equal to negation P and negation Q. So we merely exchange OR with AND 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 with OR. So these two laws are called as nothing but De Morgan's laws. So you must have done a very similar analogous law in the set theory also, so which is basically one and the same thing. It tells you the same fact. Now the third one is negation of negation is the original statement, which is almost self-evident, so nothing to explain much on that. The next one is the negation of an implication, that is negation of P implies Q is given by P and negation Q. So you take the first statement and negation of the second statement, that is the negation of consequent part. And lastly, when we want to take the negation of a double implication or a biconditional, we know that basically biconditional is nothing but P implies Q and Q implies P. So we have to take the negation of this particular statement, and to take the negation of conjunction, we know that we have to negate the individual statements and replace the AND with OR. So therefore we write the respective negations, and that is the answer. Now all of these negations can be easily proved with the help of truth tables. Okay, so as an example, let us try to prove one of the negations, that is say fourth one. Suppose we want to prove that negation of P implies Q is P and negation Q. Alright, so let us prove that on next slide. Negation of P implies Q is equivalent to P and negation Q. So let us prepare the truth table with the basic columns P and Q. Then let us have a column of P implies Q, and let us immediately negate it, so that becomes our LHS. Okay, then to build the RHS, we already have the P column. Now we have to build the negation Q column. Yes, and then lastly we do P and negation Q, right? That becomes our RHS column. So at the end we will compare LHS and RHS column and show that they are one and the same. So let's go ahead. Since we have two simple statements P and Q, we'll have four possibilities, as we already know. That is TT, TF, FT and FF. We write the column of implication. We know from the truth table that it is TF, TT. Okay, now we negate this particular column. So therefore to negate, we have FT, FF. That's our LHS. Now we negate the Q column. So that gives us FT, FT. And now we AND the column of P and negation Q. So we have to do the ANDing of P and negation Q. So that gives us F, T, F and F. So now if you compare the LHS and RHS columns, you will see that they are exactly same term by term. So therefore that proves the required negation. So just going back, we can prove all the remaining negations in similar way with the help of truth tables. Now let us practice solving the questions based on negations. Write the negations of the following statements. Okay, so that means we have to write the negation of the given statement, that is P and negation Q. So on high level, it's a negation of conjunction. So that will be equivalent to negation of first or negation of the second, correct, as per the De Morgan's law. So that is equivalent to negation P remains as it is, nothing can be done there, or negation of negation Q becomes simply Q. So that's the answer. Now the second is negation of P or Q implies R. So on high level you see that it is the implication, negation of implication. If you just remember, negation of implication, that is P implies Q, was P and negation Q. That means the first part and negation of second part. Right? So therefore this must be equivalent to first part here in the implication is P or Q. So that P or Q remains as it is, and negation of the second part, that is R. So therefore that remains as negation R. Right? So this is the required negation. There is no need to simplify that further because anyways that is not going to be anything new. So we keep it as it is. Now let us see how to do the negation of some verbal statement. Okay, suppose we are given a statement that I will either go for a movie or play football. We can immediately sense that this is the statement of the form P or Q, isn't it? Because of the word or, we come to know that it's a disjunction. So going for a movie stands for statement P and playing football is taken as Q. So the given statement is P or Q. So therefore what is the negation of P or Q? From De Morgan's law we know that it is negation P and negation Q. So therefore finally we have to write that in words, that is negation P means I will not go for a movie, and you have and here, and negation Q stands for I will not play football. So either we can write I will not go for a movie and I will not play football, that is one way of stating, or we can take some liberty and use another wording. We can say that I will neither go for a movie nor play football. So the neither nor construct also means the same thing. Right? And lastly we have the fourth question, that is a statement is that a person is successful if and only if he is rich. So here also we come to know from the if and only if clause that this is a double implication which is given to us, where P stands for person is successful and Q stands for the person is rich. So we have to take the negation of P double implies Q, and we know that this is equal to P and negation Q or Q and negation P. So to write that in verbal form we say that, you see, P and negation Q, it means person is successful but not rich, that is the first part, or there is a or in between, a person is rich but not successful, that is Q and negation P. So we merely write the verbal forms of each of these two parts and that is the required answer.